Okay, 12.2, angles and angle measurement. Um, to get us started in 12.2, what I would like you to think about is if you have an XY coordinate plane and you wanted to graph an angle, okay, not a length of something, not a number, but an angle on this thing. Think about how you would do that. We've come up with a system for that. And the system involves basically starting the angle right here on the x-axis, okay? And say I want an angle of, oh, I don't know, let's just start with 110 degrees. Okay, so what we've done is we've started the angle here, and we would put in another ray, if you would, at 110 degrees. Okay, so this angle right here would be 110 degrees. And we would call that, this angle here, where it starts, we would call this, or this side I should say, we'd call this the initial side. Okay, and this would be called the terminal side. Okay, so beginning and end. And this angle here, that's 110 degrees. Okay, and to show that it's the angle, what we can do is we can just use this little arc here. Alright, so that's cool, but what happens if we want a different angle? Like what if we wanted, I don't know, let's just say we wanted 210 degrees. So at 210 degrees, to draw that, again we would start right here. Okay, then we have to go 210 degrees. Well, if we go all the way to here, that's 180 degrees. Right, we have two 90s there, so that's 180 degrees. To get over to 210, I got to go a little bit further. Right, so it's kind of an estimate. And so we'd have something that looks like that. Okay, so standard position, initial side, terminal side. Standard position means the vertex of the angle is at the origin. Okay, so here's the vertex of the angle at the origin, and one ray is on the positive x-axis, which I just went over. The initial side is the ray that's on that x-axis, and the terminal side is the ray that rotates about the center. So you can imagine just taking that like the hands of a clock and rotating it to create this. That actually looks like a lot like what we just did. Something like 210 degrees or something like that. Okay, so that's what we're doing for the first part. So, and then angle measures. If the measure of an angle is positive, we're going to go counterclockwise. All right, so we're going counterclockwise. And if the measure is negative, we will go clockwise. So we'd start here and go into the negative. Okay, so let's do a couple of these just to get used to this. So go ahead and pause the video, draw these out, and then make sure that you did them correctly. So here we go. This is 1A, 80 degrees. If I was going to draw 80 degrees, what I would do is I would draw this guy here, my initial side, and then 80 degrees is really close to 90, so I'd probably do something like that. And I would have that angle there. Alright, so that's example 1A. For example 1B, negative 105 degrees, what I have to do is start at the same, always start at the initial position, right? And then we're going to go this way. That's 90, so I need to go a little further. There we go, we have something like that, negative 105 degrees. Alright, going this way. So ponder with a partner here. Well, I guess that'll have to just be you, but how do you think you would draw an angle bigger than 360 degrees? For example, how would you show 400 degrees? All right, so think about that for a second here while I draw this out. Okay, so 360 degrees, if you're going positive, what do you have to do? You have to go all the way around, right? Okay, so now we go all the way around and we come back 40 degrees. Okay, so notice that 40 degrees and 400 degrees have the same angle. Right? It's the same. If you just looked at this angle here, it's the same. But this swirl here that we did when we go all the way around, and typically when they draw it a little tighter. So you'd start like this, you'd go around and back, right? And then you have that guy. Anyway, that's how you would show 400 degrees, is to go all the way around and back to another angle that's on the original. Okay, So here, for example, 2, it says draw an angle in standard position that measures 600 degrees. All right, well, 600 degrees is, we got 360 all the way around, right? So we got to go all the way around, and we're not going to come all the way back. Okay, so on top of 360, we have to go another 240 degrees to get our 600. Okay, so to show that, we're going to start here, right? We're going to go all the way around, and then we have to go another 240 degrees. So we have to go all the way to here. That's 180. So 180, the difference between 180 and 240 there is 60, so we have another 60 degrees. So it's something like that guy right there. Okay, so that would be 600 degrees. We're going all the way around and back to 240 degrees. That's example 2. And then next we have coterminal angle. It says draw 60 degrees and negative 300 degrees on separate graphs. And what do you notice? So here we go. If we have 60 degrees, right, it's like this guy right here, 60 degrees. Okay, but then if we drew negative 300 degrees, we would start here and we'd go in the negative direction, and negative 300 degrees puts me right here. Okay, so it's the same angle. One is going in the negative direction, one's going in the positive direction. Those are called coterminal angles. Okay, and in fact, there's an infinite amount of these, because if you go, you can go around this, you can go around the circle infinite numbers of times. So coterminal angles, angles in standard position that have the same terminal side, can be found by adding or subtracting multiples of 360. That's just because we're going all the way around. Okay. So let's look at some of these. Example 3 says, what are some coterminals of 15 degrees and negative 45 degrees? Okay, so 15 degrees is something like this. Okay, if I wanted to know another coterminal angle, what I could do to get to that is I could start here and go this way, and if you went all the way back to 15 degrees, that would be a negative 345 degrees. Or I could just say, I'm going to go all the way around and back again. So I'd go all the way around, that's 360 degrees, right? And then back, 360 and 15 gives me 375 degrees. So those are a couple of coterminal angles. The first two that you would probably find and use. And then for 3b, we have negative 45 degrees. So let's just think about that again. So negative 45 degrees is this guy. Okay, so I could say, okay, well, that would be the same thing as positive 315 degrees. Okay, so there's that. If I kept going negative and came back, right, so if I kept going in the negative direction here, so it was here, okay, if I kept going and we went all the way around and back, that would be 360 plus 45, so that would give me 405, but it would be in the negative direction, right? So this would be, another coterminal angle would be negative 405 degrees. But you could keep going, right? You could just add 360 twice. There's a lot of coterminal angles. Anyway, for the next section here, you guys, we're going to get into radians, and then we'll be done. So a radian, what is a radian? So a radian is simply the relationship, so it's the relationship between, instead of using degrees to go around a circle, like 360 degrees, you could put it in terms of radians, which relates to the radius. Okay, so to convert from degrees to radians, you're just gonna, it's the same exact thing as pi over 180. Okay, so 1 pi is equal to 180 degrees. 2 pi radians is equal to 360 degrees. Okay, so you can use that idea to convert from degrees to radians and vice versa. So if you're going from degrees to radians, you're going to multiply by pi over 180. If you're going from radians to degrees, you're going to multiply by 180 over pi. Okay, just to convert between the two. So here it says rewrite the degree measure in radians and the radian measure in degrees. So I guess this would be degrees. Okay, so, or maybe this is radians, I'm not sure. Anyway, so 120 degrees. So for 120 degrees, to write that into radians, what you're going to do is you're simply going to take that 120, and you can put it over 1 if you want, and you're going to multiply. You want the degrees to cancel, right? So we want the pi on the top and the 180 on the bottom so that the degrees cancel out. Okay, so when we do that, The zeros cancel there. We have 12 over 18, which is the same thing as 2/3. So we could rewrite this as 2 pi over 3. Okay, so if we wanted to convert from degrees to radians, we'd say 120 degrees is the same thing as 2 pi over 3. Again, what a radian is, a radian is simply the length of a circle halfway around. So a half circle is 180 degrees, and that's equal to 1 pi radian. If you go all the way around the circle, that's equal to 2 pi. Okay, so that's 4a. For 4b, I don't know what this negative 38 stuff is. If it's negative 38 degrees, that's just kind of weird. Don't worry about this one. But if it was negative 38 degrees, okay, we would do the same thing. I'm not sure if that's what I meant to put there or what. And then you could reduce the fraction, and then it's whatever it is in radians. The central angle, an angle with a vertex at the center of the circle. When you know it along with the radius of a circle, you can find the arc length, right? So we know that the circumference is equal to pi times d, or 2 pi r, right? So if you know the vertex, the central angle has a 1-to-1 relationship, right? So if I know, for instance, that, well, let's just do this. Let's just say we have this semicircle here, right? If I knew that this was 60 degrees, for instance, and I knew that this length here was, let's just say it was 2 inches or something like that. The radius was 2 inches. Okay, if I wanted to know the length of this arc, all I need to do is take 2 times pi, and we did this in geometry, times r, which in this case is 2. Okay, so we're going to multiply those things out. And then we would multiply it by the part of the circle that we're looking for. So this would give me, if I just did this, it would give me the full distance all the way around the circle. I only want this little portion, right? This little part of the circumference. So to get that fraction, you would multiply this then by 60 over 360. That part of the circle, 60 degrees over 360. Okay, so that's this using the central angle. So here it says arc length is equal to the radius times the central angle. Okay, that's the arc length. It's the radius times the central angle. So let's do this. Example 5. A circle has a diameter of 9 centimeters. Okay, so let's just draw this out. We have, this is 9, and that goes through the center, believe it or not. Find the arc length of the central angle. Find the arc length if the central angle is 60 degrees rounded to the nearest tenth. Okay, so if we're looking at just a piece of this, 60 degrees of this, that's 60 degrees. Okay, let's figure out what the full length would be and then multiply it out, right? So this would be circumference is equal to pi times d. So in this case, that would be 9 pi. Okay, and then we're going to take that 9 pi in our calculator and we're going to multiply that by 60 over 360. All right, and when you do that, you should come out with 4.7 approximately centimeters for your length. All right, guys, that's it. We'll do some more of this in class. Catch you guys next time.